you very much, Anna, and welcome to everybody. Thank you for inviting me. It's great to be with you today. And as Anna mentioned, I'm the managing director of the Research Institute of Organic Agriculture in Hungary, called ÖMKI. This is a very nice place where we are located here in Budapest, in Hungary, our offices. And just to give you a short overview, we are a private research organization currently employing 40 people, and one is Slovenian. You could see her, Tina, on the video as well. The annual turnover of our institute is about 680,000 euros, and we finance ourselves from local and European projects. So National Rural Network project in Hungary and Horizon projects from the EU. So in this sense, we are a bit an unusual organization because agricultural research organizations are also in Hungary state-funded normally or mostly. Yeah, so our foundation took place in 2011. I think maybe the same as DAFA. And the aim was to foster scientific research of organic agriculture and also broader agroecology and sustainable food systems in Hungary at an international level. Private foundation funding of the Pancivis Foundation gave us the opportunity to launch our work. And we started off with 2012 with on-farm participatory research, which I will explain to you. This was also due to the fact that as a new organization, we didn't have own infrastructure or the funding for developing huge research infrastructure. We needed a way to start working together with farmers on their fields under real-life conditions. And then 2020, we launched a small advisory service network, and our on-farm network was accredited by the European Network of Living Labs in 2020 as well. And you see a map of Europe. Here is Hungary, and you can see that we are well in the middle or the bottom middle part of Europe with our about 6% of ratio of organic land compared to the whole agricultural land in Hungary. This amounts to newer figures, about 340,000 hectares. More than half of it is still grassland, about 40% now is arable crops, and the rest is permanent crops or vegetables, so quite low amount of vegetables. And just to give you also a bit of overview of the development of organic agriculture in Hungary from 2005 onwards, you see that there was a kind of stable or stagnating period of 10 years. And in 2015, it's quite clear that because of this new CAP subsidy scheme, this exponential, you could say exponential rise began. And you can see always when a new funding opportunity emerges, then the figures go high up again. And this means that also the number of certified actors increases, but also the area of organic certified land or under convention. So this is where we are now. And as new entrants come into the organic system, it's a challenge also to help them how to remain successful or how to comply with the organic regulations, how to switch, convert to more agroecological and especially organic principles. Coming back to the start of our work in 2012, we worked together with the people, the Swiss Research Institute of Organic Agriculture in the first years. They were kind of our mentors and supervisors in frame of the Pancivis project. And we took over this idea of baby trials, basically on-farm trials and mother trials. We couldn't start right away with traditional scientific plots trials or cattle trials or whatever, but we could start with working together with farmers who were interested in specific topics and were willing to to collaborate with us on a voluntary basis. This is still so, and we could start work together on the on-farm with the on-farm research method. So you see this also an ideal circle. Sometimes it's not so round and nice in practice, but we try to do that this way, that we define the practice-oriented question together with farmers. We fit simple experiments in the everyday practice. So volunteering farmers are executing the experiment with their own equipment on their own field among their own production technology. The data capturing is mainly done by our research colleagues, but sometimes also the farmers. We evaluate, present results back to the participants, and also we accumulate the results and present it discuss it together with them, which is an added value. And of course, we publish technical leaflets, also scientific publications and different videos or other material that is helpful in bringing the results back to practice. And you see that defining again the research question takes place then usually end of the year again. And it can happen that after already 1 year, we change the setup of an experiment. So it's not like in the traditional scientific system that we need to wait 2 or 3 years because, you know, valid results need this time. In case we see that something is really not practice proven, we change already after the first year. And of course, we organize a lot of events, involve value chain actors, other researchers. We present on field days, etc., etc. When we started this way of working more than 10 years ago now, it was really not considered as scientific. So academia was, well, nice, but, you know, a bit like a lower quality of work, not so much appreciated. So things have changed, as you have heard, also in this respect. And I put this logo on here because this is the biggest agricultural fair and conference every three years in Hungary. And in 2017 was the first time that we received an award on this event for agricultural innovation. So this was the first time that we were officially kind of recognized that what we're doing is really not bad, or, you know, worthwhile to continue. And you can see here, you can see here in the last years how many farms participated, some outside of Hungary, in Slovakia as well. We have some farmers from Romania now as well. So in different topics where we work together in our on-farm networks. And sometimes also there is a product development going on beside this research circle or cycle. This means, for example, that farmers were interested from the beginning on in viticulture, of developing local domestic plant perennial seed mixtures for covering interrow, for enhancing biodiversity, for enhancing climate resilience, which is the topic of today. For example, after 6 years of on-farm research, we could define together with the farmers 6 component seed mixture, which you can see here, and then a seed company offers this on a commercial basis nowadays. So it became known as the ÖMKI living interrow seed mixture. So it's recognizable for those who took part in its development. And what Martin mentioned, that the trust And the willingness to use it is much higher also among the neighbor farms, because they know that their neighbors used it, it works, they could see it, they experienced it, the technology is developed together, how to sow it, how to mow it, everything. So this is the benefit of working together very closely with farmers in developing new technologies. The other examples are land-raised tomato seedlings, where we took out from the gene bank different old land races of tomatoes, showing a variety of tastes and forms and colors, and tested them in volunteering organic market gardens, and afterwards it is now merchandised by one of the discounters everybody knows, but I won't tell the name, and all over the country one of our organic partners supplies the seedlings every May, so it's back again, it's available again for home growers, because there are more for home growers, but nevertheless contribute a lot to agrobiodiversity and also to more resilience this way. And these are ancient cereal wheat flowers. So it's emmer, Triticum dicoccum, and einkorn, Triticum monococcum, which have also high diversity, very good nutritious quality, but were kind of forgotten. And they provide also a very good adaptation to changing climate, and are now in the value chain also available due to a collaboration of farmers, millers, bakers, which we kind of facilitated through our research. So after a couple of years, basically 8 years, the term living labs came up also in agricultural research. You might have heard about them already in EU calls. You can find the living lab approach quite often as something that is wished for. And we were doing basically the things that a living lab should do. So a living lab is user-centered. It's called an open innovation ecosystem. So anybody can join in and bring in ideas or do something for the joint aim. It's a user co-creation approach. So it's not the researchers saying this, hey, this is what we should do, but it's a work together. And it happens together with the real life communities and the real life settings. So you can see these keywords, and basically what I presented you, our own farm network complied with this. So that's why we got accredited in 2020 as a living lab. Living labs were more prominent in very different sectors. So not agriculture, but pharmaceutical companies or tech companies use the living lab approach to test, design, and fine tune their new products. And in agriculture, it's still a bit unknown, but it's more and more becoming common to use this approach. So I brought you a more detailed example, our cereal variety tests, to show a bit how it works in practice, these on-farm trials, and how we managed to develop them further with the mother trials, which we imagined at the beginning. You can see here in the video, it was also visible, these are strip trials, different varieties of winter wheat beside each other on a farmer's field, and colleagues are assessing disease and pest damages on different stripes here. So that's what we do. Usually farmers select 5 to 7, maybe 10, that's maximum varieties of winter wheat offered by our colleague coordinating the living lab. And they saw it on their fields. These are 51 locations from 2012 on, where winter wheat, spelt, emmer, and einkorn on-farm variety tests or land-raised tests in case of ancient cereals were done. And these are the baby trials, let's say, but I showed you before in the schematic depiction. And from 2020 onwards, we managed to collaborate with institutions like the Seed Association in Hungary and the National Food Chain Security Office called NEBIC, and with different other research organizations, universities, research centers, and breeding centers, like in Martonvásár, if you know, maybe, and 7 locations for small parcel variety testing in under organic certified conditions could be set up, where, of course, on small parcels with the traditional scientific setup of 4 replications and randomization, a lot more varieties can be tested under more controlled environments. So it complements very well the on-farm network. And the aim, of course, is of the whole thing to enable evidence-based recommendation of varieties of cereals for organic production in different regions of Hungary. So that's important also to keep up with the climate change effects, because it's for example, last year was the heaviest drought ever in this part of Hungary, the southeast. And this part of Hungary is considered by FAO as semi-desert. And also the precipitation, as you know, due to climate change is not only less and less, but the energy and the amount which comes down at once is also extreme. So all this needs to be taken into account when you choose a variety or even a species like an ancient grain for growing under organic conditions. Of course, pests and diseases are also very important. So we can select, for example, and explicitly show which wheat varieties are susceptible, for example, to fusarium fungi, which you might know that they can produce toxins, which are also very bad for human and animal health. So these varieties, of course, should not be used under organic conditions. And in such a year as this year, where we had quite a lot of rain in June and July, we can select and say explicitly these varieties are not worthwhile to grow under organic. So this is how it looks in practice, the small plot trials, and some graphs to show results. This is a typical on-farm result of a wheat variety testing. This column is the average result of these 2, 4, 5 varieties that this farmer tested in the northeast of Hungary. And the colors represent different quality of the wheat according to a standard, a Hungarian wheat standard. This one is the best. And it's these dots represent the protein content in percentage, and the columns are the tons per hectare yield. And you see that, as usual, the highest yielding is the lowest in protein content and quality. But there is, for example, this Austrian variety, which was already bred for organic farming. So organic breeding is the best in quality with a quite good, reasonably good yield. But also some of the Hungarian varieties, which were bred under local conditions in the lowland, have a quite good result. So this is what comes out for one farmer, which he or she can use afterwards for making decisions. But we can also see here the results of the small plot trials. This is the results of accumulated results of the first 2 years from all 7 locations. So we can also make overall conclusions, which yeah, might be also helpful if you don't find your own region among the 7 locations. And here you can also see that this is the yield. Of course, the highest yielding has then almost the lowest quality. This is also one of an Austrian variety, which we test. But there are, as you can see, these red lines are the average values. Some that are over average in yield and around average in quality, which can be a good choice overall. And if you really want to do very high quality, this is a control old variety, which has traditionally a very high quality, as we use it as a benchmark or standard, but you see the yield is very low. So you have almost the same high quality and a bit higher yield than this traditional. So you can choose according to your own strategy which variety you need in your farm, where you want to head on the market. So that was just one example of how we can support the conversion or the successfulness of organic farming through this living lab approach combined with traditional scientific experiments. And to sum up, you see that yearly more than 100 farms take part on in the different topics we do. We have different products, different new technologies that are also adapted right away in practice. I mentioned these already. We worked a lot, you could see in the video as well, with bee health management, with acids and natural materials, and technology support, also introducing also ancient cereals into the value chain. And as I mentioned, our funding is 1/3 almost from EU projects, Horizon projects. The Living Lab approach is quite helpful in getting involved in different EU projects, as it is sought for. And of course, Central Eastern European partners are also always sought for. So I can only recommend to colleagues listening to try to get engaged in these EU projects. It's always very nice. For example, in Diversifood, we got the first materials of ancient cereals in this project. We could test them due to the project. And already we got involved in developing the European network of living labs and research infrastructures, which is one of the assets aimed for in the agroecology partnership in Europe now. And so it gives a lot of opportunity to become engaged in international research and policy making, as well, research policy making. So to come to an end, these are the advantages, I think, of working this way. And I will show you also some challenges on the next slide, not to be only one-sided. So for the farmer to take part, I think he and she can learn new practices, validate the information on their own field, and most of all, become a part of a community and a professional network. We have a problem that farmers are often isolated and don't have, organic farmers typically don't have a network or such a background of community, and this helps them also to get in touch with each other and learn from each other. For us, for researchers, I think it's very motivating to answer real-life questions and challenges, to be connected with the everyday practice. And I mentioned also the international project successes. And if we think big in terms of society, it increases not only the sustainability of the food system, but also the competitiveness, because we have to change. Everything is changing around us, not just the climate, but also the market and the needs of consumers, the policy targets, everything. So you have to keep up. And it's important that such a collaboration might be more attractive also to the younger generation. We face a big issue with new entrants into agriculture. The average age is quite high among farmers. So this is also a way to make agriculture more sexy, let's say. And I wanted to show you some of the challenges also of working as a living lab. So Martin already mentioned that multiple competencies are needed. So it's not only the researcher in the traditional sense, but the person needs to communicate well also with farmers, needs to have an organizational skill to bring everybody together, build a community, needs to facilitate a participatory processes. So it's quite rare that one person is competent in every field. So in the beginning, we could really do this with one colleague each topic. But now, as we go deeper into some topics, we recognize we need two, or also to organize, for example, economic assessments or societal social sciences, we need at least 2 or even 3 people for one project, one living lab topic, which means that it takes also more human resources. And as we grow, because in 2012 it was me, myself, and I, and starting ÖMKI, and now we are 40 people. So we need to train ourselves internally as well to keep up, to benchmark our living lab activities, to really bring this cycle to a possibly ideal realization, and so that there is no disconnection of what I'm preaching here about living lab methods and what my colleagues or myself do on the field in reality. So we are organizing now our first internal living lab training for colleagues. What is also challenging is to explain the living lab concept externally. So to local academia and policy making, it's a quite complex concept, and sometimes it's perceived very differently, or it was already heard but not well known, or something else was understood, and it's an effort explaining it. And of course, in the practice, then, if you work with the actors of a value chain, the communication, ensuring that things really are done the way they are supposed to or were conceived, it's also a challenge because, under real life conditions on a farm, many things can happen. Priorities may change, or accidentally they forget to measure a yield value, for example. So you have to have a flexibility and a higher number of partners so as to ensure that in the end there are enough reliable and good data and results, so you can go on and draw conclusions based on it.